Today I'm joined by Dr Sarah McKay, neuroscientist, science communicator, and author of the Women's Brain book. Sarah has spent decades translating complex neuroscience into practical, empowering knowledge about how our brains work across the female lifespan. Her work helps us to understand something many women perhaps wonder about: what is actually happening in our brains as we move through midlife. Because for many of us, this stage of life can feel like a turning point. Our priorities shift, our bodies change, and we begin asking deeper questions about who we are and how we want to live. In this conversation, we explore how understanding our brains can help us navigate these transitions with more compassion, curiosity, and confidence, and why the years after 50 can be a time of growth, clarity, and reinvention rather than decline. Sarah, I'm so delighted to have you here today. Welcome.
Oh, thank you for the invitation. I'm always up for a chat.
Chat about brains.
My
Here we
favourite
go.
things.
What sparked your curiosity about the brain?
Oh gosh. So I feel like this is a bit of a well-worn story now. So first year university back in 1993, we didn't do neuroscience at schools back in the 90s. And I was in a Psych 101 lecture and we were doing the biology of psychology. I was at Canterbury University. I grew up in Christchurch in New Zealand, and we were having a lecture on synapses, which are the connections between neurons, and I'd never heard of them before. And I just thought, get out, these are like the coolest things I've ever heard about in my life. Honestly, honest to God, I was just captivated. And we were also recommended, and now I've just completely rearranged my office, so I don't know if I've got the book lying around anywhere. We were recommended to read a book by a neurologist called Oliver Sacks. If I can see it, I'd grab it, called The Man Who Mistook His Wife for a Hat. Now, whether these were real case studies or maybe there was a little bit of kind of woven fiction in there, he wrote these case studies of the things that went wrong with people's thoughts and feelings and behaviours when things went wrong with their brains. And the man who mistook his wife for a hat used to, saw a person and thought they were a hat, or saw a lamppost and thought they were a person. He had this strange kind of visual agnosia. And I was just captivated. And so I changed universities to Otago University in Dunedin in New Zealand, thinking, well, I'm just going to go and do a degree in neuroscience, because I just pulled together that as a brand new discipline in the early 90s. And that was it. And that passion and that enthusiasm and the surprise and the delight with the neuro, which is so nerdy, just still happens now. I can pick up a new paper, there's a new finding, someone's published an article, whatever, about neuroscience, and I still think it's so cool and interesting. And now I suppose, I spent many years, went and got my master's and PhD and worked in medical research. Now I work in science communications, and I get to talk about the brain and talk about neuroscience to other people. So it's my kind of two favourite things, just having a good chat and neuroscience.
And it sounds like your neurons were just lit up from the get-go.
They still are. They still
Right?
are. And I think that neuroscience is so broad and deep and complex, and there's so many ways we can sort of zoom on in and look at molecules and neurons and synapses and genes and look at everything under the microscope, and then you can zoom out and look at people and their behaviors and actions and thoughts and feelings, and then we zoom out a bit more and look at social connections and communities and how people interact, and then zoom out even more and take like global or a public health perspective on brain health. What do we see shift and change when we look in different countries in the world and different socioeconomic circumstances, or there's so many ways you can zoom in and out. So it's endlessly fascinating. Yeah.
I love that. You never get bored. There's always something. It's so broad, isn't it? But it just comes back to the brain, which is amazing. You've got all these different avenues that you can explore. So what led you to focus specifically on the female brain and write the Women's Brain book?
Yeah, again, that was a bit of a, my career has always been sort of a series of things just doors opening it's been very unstrategic. And this is quite unstrategic, although I'm trying to be more strategic as I get older. I was writing an article for the ABC here in Australia. I used to write this brain blog for them, and I'd write a different article every week about all things brain. And there's endless, as I've just said, things we could talk or think or write about. And I just happened to, with the editor, come up with the idea of writing an article on brain fog and menopause. And this was in 2015, and I wasn't invented then, or at least, I mean, it was invented, but it wasn't a thing. No one was talking about menopause. I wasn't. No one cared. Turned out people did care because I wrote this article, we published them all, and then it went on Facebook, and this article went gangbusters.
Facebook. Yeah, I bet.
Thousands of comments, shares. You can go and you can see that Facebook post still. It's like looking back at ancient holy texts, because the conversations people were having in 2015 compared to now, it's almost like looking back 100 years in time. It is so crazy. And then that was that. And we were like, well, that was kind of weird. People, menopause and brain fog, whatever. Didn't think about it. Just carried on with my weekly blog. And then I was approached by a literary agent asking if I would like to write a book. And I was like, oh gosh, that seems like a lot of writing and I don't really have an idea. And she said, well, let's meet and chat about ideas. And so we meet and chat, which is my favorite thing. And then she said, oh, what have you written? And I said, well, I wrote this article on menopause and and brain fog. And then she said, why don't you write a book on that? And I said, well, there's no neuroscience. No, I'm not. That's like weird. Not weird, but it's like, that's too niche. And then she said, well, what about baby brain? And I said, well, there's not a lot of research on that either, but I don't think that that's a thing because knowing what I did about the brain and neuroscience, it was like, well, what would be the adaptive benefit to become more stupid when you have a baby? Like baby brain, I think is not real. I don't believe it's neurological or there's a neuroscience base to it. And then I was like, oh, baby brain, menopause, brain fog. And I thought, well, I know a little bit about puberty and the brain, and we've got menstrual cycle. And what about the pill and anxiety and depression and Alzheimer's disease and dementia and boys and girls? And then I started to go, oh, I could write like a book, like across the lifespan, looking at how our brains are shaped and sculpted by, virtue of the fact of growing up female and the experiences we have. And so that was I had this kind of muddly idea in my head. And so my agent said, go away and write a chapter outline. And I thought, well, I just have to be logical and methodical. And so I wrote the chapter outline, kind of womb to tomb, and each chapter was a different life stage. And each subsection in the chapter was essentially a question I didn't know the answer to and got snapped up. It felt very niche. 2016 was. No one was writing.
But
there were a
isn't
few
that
sort of
just
studies out there, but no one was writing about it.
No information no studies done on menopause and brain health in perimenopause and menopause.
There were a few,
but not enough.
But it was kind of curious that, and then I know lots of neuroscientists and I know how to do research and I know how to, interact with the people doing the work. And so I started to get a bit of a lay of the land of what was going on out there. And it was almost, like sometimes the timing is just right. And while I was writing that book, the first study that came out looking at how women's brains change across the course of their first pregnancy, what we would now understand as the neurobiology of matrescence, that was published. And so I got in touch with the researchers to talk to them about, their work that came out literally in the middle of the book. And then I ended up writing a whole book on the neurobiology of matrescence called Baby Brain, as I got to know all of the researchers in that space. And it's sometimes it's a little bit like you don't know what you don't know, and a new study can come out that can crack open the door to a new discipline. It's almost like, once the 4-minute mile was a thing, then everyone started going, oh, the 4-minute mile is a thing. We can all run the 4-minute mile. Sometimes that's just what happens. And so, yes, there has been neglect about female biology, female neurobiology, what's happening in women's brain health across the lifespan. But there have been a lot of studies done. It just hadn't been kind of pulled together as a discipline with people working in this space. There's many reasons for that. But what we're starting to see now is scientists are pretty good at understanding data and recognizing the gap and understanding that we need to integrate sex as a biological variable and look at women's brain health. And this isn't actually a niche. We've also seen the maturation of, there's always been gender equality in the neurosciences and medical sciences, not in all STEM subjects, but, neuroscience has always had gender equality. And I think what we're seeing as well is the maturation of like my generation, Gen X, now kind of heading up the research labs, asking questions about their own biology, getting access to the research grants and the funding bodies and the journal publications. Everyone's sort of, it's almost like everyone kind of had an aha moment around the same time I had an aha moment, sort of 2016. And now the research is coming in. That said, and it's not, and I'm super optimistic about what's happening and what the change is. There are some fields of women's brain health or female neurobiology that are really well studied. There's not no research. It's pretty easy to go, well, there's no research, we don't know anything. There's actually quite a lot of research in some interesting spaces. Sometimes, isn't what people want to hear. Other times it's amazing and it validates people's experiences. So my job, I suppose, is to communicate that, kind of be that bridge between the work that is being done out there, get it out there into the world. Some stuff's been since the 60s and people don't know about it.
Yeah.
We've been looking at how the brain, like female cognition, how the brain thinks and different types of cognitive tests and executive functions of the brain, things like memory, things like attention, things like processing speed across the course of the menstrual cycle. We've been looking at that since the 60s. That work is out there in the world. And even the research that's done now validates the work from the 60s. It's just sometimes it hasn't filtrated out.
Yeah. And clearly there's a need for it, isn't there? And from that reaction to the Facebook page, women are wanting that information. We're hungry for it, right? After being perhaps suppressed for so long about talking about it. And now there's just, we want as much information as we can get.
I think the little bit of a problem there is whenever there's a gap, the scientists are like, okay, well, we're going to fill that gap. Science is by nature of science and the way that we ideally want to do good science is careful and thoughtful and methodical. And it's not that the science isn't filling the gap fast enough. The science is filling the gap as the science should. It's just a lot of other people kind of rush in when there's a vacuum, like the commercial side rushes in. And because women are desperate for answers, there's some players in that space that are answering those questions, but not necessarily with the careful, thoughtful, methodical data. And so it's an interesting kind of friction in there right now, which I'm quite enjoying, but also not enjoying because, of course, the thoughtful, careful, methodical science. Like we can't just shout crap. We've got to be talking about what we do know and what we don't know and not being afraid to say we don't know or we don't know yet. Good science takes a long time. Ideally, what we want when it comes to understanding women's brain health at any point in the lifespan is like, say, what we would call a longitudinal study, which is very boring to get into the data and the statistics. But ideally, we would get like a big group of women, 1,000, 10,000, and follow them kind of across the course of their lives, a bit like we were making a movie of their lives. And we could watch the character development of each person and we would see cause and effect and we would understand each kind of scene and scenario of their lives, not just take a snapshot of them at any one moment in time and assume the average of those women is everyone's experience. A longitudinal study of something like pregnancy, well, it's only 9 months, right? So, you could do it over the course of like a year if you've got enough women pregnant at the right time. Menopause is going to take a whole lot longer because ideally we'd probably start studying someone in their early 40s and finish studying them in their 60s. So that's a 20-year study,
it's a long
right?
time.
We can't speed time up yet.
Yeah.
And so at the moment, for something like menopause, we can only take snapshots in time of women in different ages and stages. And then unfortunately, we take the average of those women. And there's always going to be a normal distribution of outcomes. Some women are going to have one experience at one end. Some women for menopause are going to be like, flat on the floor, brought to their knees. Other women are just like, it's fine. Like, what's the fuss?
Yeah. So what is that?
We're trying to average them out and say everyone's experience is the same. So we're kind of at an interesting point with menopause research, and particularly then casting forwards into aging brain research and seeing the links there between midlife and late life. Early childhood we're kind of getting some childhood cohorts maturing, and then the few longitudinal studies where we've got cohorts of people we've followed from birth in their 80s. There's some in Harvard, there's some in New Zealand where people are in their mid-50s. I'm looking forward to seeing the menopause research emerge from that.
Interesting.
Yeah.
So when you began researching this space, Dr. McKay, what surprised you most about how women's brains change across their life?
I guess, well, the biggest surprise was the study that came out looking at pregnancy. And that came from a group, Elselina Hoxema, who's Dutch, who was working in Spain at the time. She's now back in the Netherlands. Susanna Carmona and Erica Barber-Muller and their research group. That was the first study looking across the course of a first pregnancy. And there was this 4% kind of volume change in women's brains across the course of a pregnancy, which we now know, thanks to subsequent research, is driven by the hormones of pregnancy and then consolidated by the acts and behaviours of mothering. That was the biggest surprise, was how striking that was, and the parts of the brain that changed, which are involved with social cognition. So thinking, empathy and theory of mind, what someone else thinks and what someone else feels, which is going to be the baby, right? So pregnancy's changing the mother's brain to enable her to become a mother. What we now understand is this word matrescence, and it's a neurological and biological change. So that was perhaps the biggest surprise for me. And then the outcomes of that change were, more flexible, efficient, responsive brains that are better at doing what they do. I guess what I kept coming up against was, and it wasn't a vibe I'd grown up with, that hormones break brains, and if you've got a female brain, you add in some hormones, you're going to be angry at puberty, you've got PMS, you'll get postnatal depression and then brain fog at menopause. I'd never grown up with that kind of narrative, partly perhaps because the women in my family didn't have that experience. So I wasn't expecting terrible things to happen to me or to feel anxious or depressed or foggy. But lots of women do have that experience, and there was a bit of a default that as soon as you've got a female brain, you add in some hormones, things will just kind of go wrong. Instead, what I found was that at every age and life stage, the greatest source of like that vulnerability or perhaps resilience was other people, was the social context in which your brain is acting and trying to work within. And so that was the biggest surprise to me, and is still a message I try to get out, because there's a lot more agency in relationships and social connections and that kind of outside-in action on a brain versus simply thinking it's about like the interaction between your brain and your ovaries and being kind of at the mercy of a hormonal roller coaster. So for me, that's the biggest surprise.
I have to ask, how do women's brains actually differ from men's brains, if at all?
Good question. So if we look at a brain, any brain, yours, mine, my son's, my husband's, whatever, there's 1,000 things we could look at. We could look at like kind of overall size or volume. We could look at grey matter, which is kind of the wrinkly outer coating of the brain. We could look at volume of different regions, thickness. We could look at white matter, the connections between brain regions, how, we could look at just like how it looks, how it functions. We could do an MRI, look at structure. We could do an fMRI, like functional brain imaging, and there's lots of different ways we can image a brain and look at networks and connectivity and activation just while a brain's lying there doing nothing, or in response to various kinds of cognitive challenges or tests. We could look at how different parts of the brain react and respond to, to hormones or to faces of other people, or, across the course of the lifespan, vulnerability to, mental health conditions, et cetera, et cetera. So you've got any one brain, you could take 1,000 measures of that brain, 1,000 metrics of that brain, and then compare that to one female's brain and one male's brain. Which of those measures are we comparing? And how much difference do we see? We've really got to do science properly and look at, like, say, 1,000 female brains and 1,000 male brains. And then we've got to compare like with like. So we can't look at, say you've got these 5 people. We've got, like, say, Sophie, who's like a 9-year-old girl in Dublin in Ireland, and she loves Taylor Swift. And then we've got my son, who's just headed off to university to study maths here in Australia. And then we've got, say, someone in rural India who's about to have her 3rd baby. And then we could go, like, say, to Argentina and look at, like, a 60-year-old lawyer who's got a very kind of well-established law career, and then we could go to New Zealand and look at, like, say, someone who's elderly in a nursing home who's in their 90s. Are
Hmm.
there, are we going to compare each of their brains and say the differences that we see are solely due to biological sex, or to life age, or to life stage, or to the experiences that we've had? So we've got to compare like with like. We've got to look at brains that are the same age, the same life stage, that have had very, very similar experiences. And then we can start saying, if we see differences, how different are those differences? Which, are we looking at volume? Are we looking at susceptibility to disease? Are we looking at a cognitive test? Do we see that across all people of that age, life stage, and biological sex? And then what's driving that? Is that due to hormones? We're not going to compare the brain of a woman who's pregnant with an 18-year-old person going to study male maths graduate, right?
Sure.
So we've got to compare like with like. And once we start doing that, sometimes we see differences and sometimes we see similarities, depending on which metric we look at. So the answer's not really very straightforward. Of course, females have got a part of their brain which controls ovulation. Males, of course, don't have that.
Yeah.
There's one study that looked at comparing brains, biological sex in different countries in the world, looking at different rates of gender equality and inequality in those countries. And in countries where there was more gender inequality, then women's brains and men's brains were more different when they were looking at one particular metric of grey matter volume.
Interesting.
In countries where there was more gender equality, the grey matter volume differences disappeared. So that must be due to how the women in those countries have grown up and had less access to education and opportunities compared to the males. So it's not like looking at someone's genitals and going, well, are there differences between males and females? Of course, there's differences in genitals. But looking at, like, I don't know, fingernails or rates of hair going grey or which cells make up your heart, there's lots of similarities.
So we don't have a good excuse. I've got 3 males in my house at home. So if they're not
Well, I don't
operating
think
the
we should be
same.
using biological sex as an excuse.
Yes,
And
no.
this has been the problem for a very long time with this idea of sex as a biological variable and also taking into account of gender. And the word gender now is quite loaded. I would use gender to mean the sort of the social experiences and expectations that we have based on our biological sex, not gender identity, which is a whole separate thing.
Sure.
So scientists or neuroscientists have been kind of reluctant for a while to kind of talk about biological sex differences that we see in the brain, because often they get used to reinforce gender stereotypes. And also because we just didn't have data where the signal was emerging from the noise. Science is going through this kind of renaissance right now because we've got data sharing. I can be in a research lab here in Australia and I can put all of my data into kind of an open access biobank of information. So can people working in Oxford, so can people working in Harvard, so can people working in, different parts of the world. And then we can pull all of that data together. And then we've got things like machine learning and AI that can analyze large amounts of data quite easily. And we start to see little signals emerge from the noise that we couldn't see when we didn't have enough data. So we've got different ways of thinking about the brain now as well, which I think is fascinating. I don't think that we should be using biology to excuse bad behaviours, rather be really open and curious about when we see differences, what's perhaps underpinning those differences, where do those differences come from, how big are they? Often they're quite small. Often there's massive overlaps and standard deviation curves. And I know that this is all very boring because it's just
No, I love
science
that.
and data
No.
and statistics.
No, I love that. Back to the female brain across a lifespan. So why do you think so many women reach midlife feeling like something has shifted internally, mentally, or emotionally even, but can't quite explain why? Is it just hormonal or is it something else?
Midlife is that's an interesting, because I don't think we have a really good clear story in the same way that we do for matrescence, where it is very clear there's a significant neurological shift and an adaptation of the brain to pregnancy to enable us to mother. Some women aren't very good at it, but that's another whole story. Midlife is when we haven't really got a very good clear story of how the brain is changing across midlife. and we could look at, say, ages 50 to sort of 65, say that's midlife. We've got sort of 25 years of aging in there, 25 years of life lived, the difference between the year 2000 and now. And sort of somewhere in the middle of that, depending on where that happens, we've also got menopause. We've also got perimenopause and menopause. And that could extend, that could be long for some women. It could be quite short and defined for others. We don't have a very clear story yet. But if we're thinking about what happens in the brain, it's hard to tease out menopause and aging. It's like trying to tease out puberty from adolescence, because the two kind of go together. It's like comparing the brain of someone who's 8 to someone who's 18. Are the changes that we see in that 10 years due to aging, getting older? Yes. Are they due to puberty? Yes. So it's hard. We can't kind of control for one versus the other. And especially when you've got 25 years of brain aging, right, from 40 to 65. But there are like kind of about 5 or 6 things that we know that are happening, but we don't know how they react and interrelate. We're not sure what's the domino effect. Or if we were to just draw a diagram, is there lots of arrows?
Yeah. What are those 5 things?
Those 5 things are with changing levels of estrogen during perimenopause and then into menopause. So this could happen in the space of a year, or it could be extended out to 5, maybe longer years. So ovaries are getting tired, they're just wearing out. That's kind of what's driving it. We've got the roller coastering of hormones. We know that alters what happens in the hypothalamus, which is the part of the brain which controls like our breathing, our heart rate, our temperature, etc. And we've got a very clear story there about levels of estrogen and vasomotor symptoms or hot flashes. And that's because our reproduction and our reproductive fitness and our body temperature are very tightly correlated and need to be very tightly controlled. When we reach our reproductive senescence, we're not having babies anymore. It doesn't really matter what your body temperature is. So there's no evolutionary drive for that to be regulated. It doesn't matter if you're hot or cold if you're not reproducing anymore. Like there's no drive for that. So we're just kind of left with maybe very dysregulated body temperature. So we've got what we call vasomotor symptoms or hot flashes. So there's that change there. Linked into that is kind of the mechanisms by which our body is trying to react to dysregulated thermoregulation in the brain. So we've got our autonomic nervous system, which has got sympathetic and parasympathetic branches, and that's about kind of regulating and mobilizing you to act and then kind of bringing you back down to baseline. And there's a balance between the two. Repeated sympathetic nervous system activation, which happens as part of trying to regulate your temperature, is partly responsible for waking you up at night if you have unmanaged vasomotor symptoms, because your brain is trying to wake you up to cool you down, which is throwing the covers off or putting the covers back on. And repeated sympathetic nervous system activation is very closely related to feelings of anxiety or hypervigilance or that kind of wired edginess, but also tiredness if it's disrupting your sleep. And that can very easily tip over into anxiety, because if our nervous system's kind of feeling edgy and irritable, our brains, our default mode networks in our brains do not take very long to find something to worry about. There's an edginess in our body. Our brain's going, why am I feeling like that? And you'll cut, like, if you're 50, you'll find something. It won't take more than 10 milliseconds to find something. Well, that's the thing to worry about, right? Yeah. So our brain's trying to fill in the gap. Our brain's a prediction machine. It's going, I'll find something. And then that kind of compounds itself. So that's the second thing. The third thing is we know that the changing levels of hormones and also getting older and also perhaps disrupted sleep change how well our brains and the neurons in our brains are able to kind of produce energies. Cellular metabolism, which involves things like mitochondria, which you might remember from high school or have a little bit of an understanding of. We know that they may get a little less efficient at kind of creating energy. And some women, some of the time, not in all women all of the time, because there's many complex biochemical circuits at play here. And it could be that the brain's metabolically a bit worn out and it's feeling a bit tired, so it's kind of harder to process. It might need to recruit more neurons on board to process information and get the job done. So there's that shift in metabolism, maybe related to the shift in metabolism, or maybe related to something completely different, maybe completely driven by hormones. We don't know. Are the changes in brain networks. So as you go through puberty, different kind of groups of neurons in the brain form quite well-established networks whereby these neurons will come together as a group to get a job done. And as we age, we see this during aging, And also, we don't know whether it's driven by hormones and aging, or aging alone, or hormones alone, but men do this too, so it's probably aging. We start to see networks, instead of becoming very segregated, they become more integrated. So it's almost like the brain is adapting, going, hey guys, we need more players in the team to get the job done. So the brain networks will start interacting and cooperating together. So the brain adapts and responds. So that's like the fourth thing. And then the fifth thing is hormone levels are directly impacting levels of neurotransmitters and neuromodulators in the brain. But like, say, GABA or serotonin or dopamine or glutamate. But I'm kind of a little less thinking that that's underpinning things. Maybe it is, maybe it isn't. The biological mechanisms there are a bit more fuzzy. And so we've got these 5 things. We've got the vasomotor symptoms, the sympathetic nervous system activation, the metabolism of neurons, the network adaptation, maybe the direct impact on neurotransmitters. What does that feel like as we're experiencing life? Sleep disruption is inevitable. And what's inevitable if you have one night, a week, a month, years of bad sleep is feelings of what we might call brain fog, changes with higher order things about like verbal memory or verbal gymnastics, where you might like use the wrong word to describe a thing, like, you know, you might say, oh, that's a nice lid when someone's got a nice hat, or you might say dishwasher instead of washing machine. And the reason we notice that, I believe, partly is because that's typically in a conversation with someone else. And so we say the wrong word and then we're like, oh my God, I just said the wrong word. How embarrassing. And then, or that other person might notice. If you've got teenagers, they'll call you up on it. So you kind of notice that type of thing, which is interesting.
So that's a normal response to perimenopause, menopause. That's not us needing to panic going, oh my gosh, is that early onset dementia?
No. All those stories, no. That's just kind of normal, and we notice it, and so then we worry about it because everyone's freaking out about Alzheimer's and dementia as if that's inevitable because of menopause. We don't really understand. We don't understand that link. We've got anxiety in there because of our hypervigilance. Perhaps you've even developing depression, especially in those women that have a prior history. You don't typically get new onset depression as frequently as you get recurrence of prior experiences of depression. And the more times you have depression, the more vulnerable you are in the future if you had it as a teenager, postnatal, etc. So we've got this kind of collision of all of these things that are happening and changing. And then our brains will also be paying attention to certain things and not others. And what we remember and process depends on attention and where, how much information we take in, what we filter out. We've got these things here, which like mobile phones. We carry these around like a little precious little baby in our arms. When we go through pregnancy and motherhood, your entire attention is captivated by your baby. And so you're not paying attention to everything else. You're filtering a load of stuff out. So of course you're not paying attention or remembering that. And so when we go through matrescence, we call it baby brain. Now, as middle-aged women, we're not carrying our babies around anymore. We've still got teenagers and parents and things like that. We're carrying these little babies around. And like, if you put your phone down, you go, oh my God, where is it? Oh! Like the same way you would if you put your baby down somewhere and forgot about it. So much of our attention is sucked up by that thing.
Yeah.
And again, we're going, oh, it's hormones.
Is that because we're also getting like a dopamine? Are we trying to get like a dopamine hit from these phones as well? Is it giving us something?
Much about a dopamine hit. It has become so incredibly salient, like a newborn baby, that it's not about wanting a dopamine hit. Essentially, put it face down next to me at dinner or whatever. We have really good research that's showing, this has been validated multiple times, that if we do a cognitive test of someone, we're looking at something called working memory, which is just the ability to, like, say, do mental maths, like remembering and holding ideas in your mind's eye. And that underpins every other function of cognition in the brain. That if you have a phone with you, you'll score worse on those tests than if the phone's turned off and it's in another room, because it's become so important to us that we're constantly looking for it, and it's almost like we're multitasking, kind of paying attention here, and we've got, the phone. Oh, no, not the phone. I'm not going to think about the phone. I'm going to focus here. So it's like a baby. It's like trying to ignore a baby. It's just consumed us. And that's reducing our working memory capacity, which is then reducing other functions. So it's not just, it's a hormone or it's dopamine. It's a bit more complicated than that. So we've got a lot going on. And then if we're 50 and we're on social media, we're getting bombarded with these glossy, like beautiful messages from these, charismatic social media influencers and doctors, etc., who are making this direct link from menopause to Alzheimer's and dementia. And we've got aging parents and we're worrying about that. And we don't understand necessarily the link between the two. But if you're in the Alzheimer's and dementia space and you just look at that data, and I'm always coming back to numbers and data or else we're just speaking crap. We constantly hear, 2 out of 3 people with dementia or Alzheimer's are women. We've got to understand the difference between prevalence, which is the number of people alive with that diagnosis, like the people swimming around in the bathtub of dementia, and the inflow rate, like who's coming in through the pink tap and who's coming in through the blue tap, like the males and the females, and then who's flowing out the plug hole. Men flowing out of the plug hole earlier because they die off younger than women. So that means there's more women floating around in the prevalence pool. That inflow, who's coming in through that tap, is actually pretty similar rates of males and females up until about age 85. It's not like the pink tap's on full bore and the men aren't coming in. Both taps are flowing in, the men are flowing out, and then once you hit age 85 in healthy, wealthy countries, then you start to see more women flowing in. And there's lots of reasons for that. It's not just because of menopause. It could be all the way back to early life education and enriched opportunities. We've already got that well established. In low and middle income countries where women don't have the same access to opportunities in healthcare and education and enriched opportunities, that pink tap is flooding it at a much higher rate at a much younger rate than it is for males. So in different countries in the world, the inflow is changing. Now, we're all going through menopause. We've all got hormones or not hormones, etc. If it was purely biologically driven, we wouldn't see differences in different parts of the world and different generations coming through. People who were born in the 1910s and 1920s were far more vulnerable to develop Alzheimer's disease than people who were born in the 1940s and 50s. And we're seeing that globally. We're seeing the inflow decreasing. So we've got to understand these differences between the inflow and who's in the pool and who's flowing out the plug hole. Because if we just look at the basic stats, then the glossy influencers are busy telling you that it's all about menopause. And that's the reason why women get dementia and men don't, which is not the case. I'm not glossy enough I'm trying to counter that by using science.
It's great
which is quite
to get
hard.
this information. Yeah.
Because then we can look at all of the things that go on throughout our lives which can contribute to risk. It's not just your hormones at menopause. And we've got all of these things out there which is super unsexy, like hearing loss at midlife. We don't have hearing loss influencers on Instagram saying 7% of cases of Alzheimer's disease are caused by untreated hearing loss at midlife. We need some hearing loss influencers. High LDL cholesterol. I mean, I suppose there's like the fitness, heart health influencers are doing a reasonably good job. We've got social isolation, particularly in late life. That's not very sexy or cool. Vision loss in late life, that's about sort of 3 to 5% of cases of Alzheimer's disease. Because you think if you can't hear and you can't see, you can't interact with the world. Again, that's not sexy enough. What we've got is we've had this gap in women's health. We've got the influences flooding in.
And it's almost blaming the hormones again,
Blaming the hormones.
Yeah.
It's probably one little piece in the puzzle, but if we're looking at the data and the statistics, it's not that hormones haven't been considered. I always say it's like these old-fashioned scales where you've got your risks on one side and your protective factors on the other, and we've got various weights we can put on. We know what's protective, we know what's a risk. When it comes to hormones, and particularly hormone replacement therapy or menopause hormone therapy for midlife women, we don't know how big and heavy that weight is and which side of the scales it goes on yet. Right now, it's probably net neutral. But right now, it's got the headlines, and it's got this
neutral
basic
in
default.
terms of effectiveness.
We don't know which side to put it on. We don't know whether it's going to be beneficial or risky, because in some women it might increase risk, in other women it might decrease risk. We don't know how big and heavy it is. So we don't know which side of the scales to put it on. Hearing loss, massive, big, heavy weight that's going to increase your risk. Hormone replacement therapy, we don't know yet. The data's, it's kind of, and even the really sophisticated ways of doing very complicated statistical analysis, looking at people's genes. There's this technique called Mendelian randomization, which is I'm not going to get into because it's complicated. Again, the studies that are looking at that keep showing hormone replacement therapy is net neutral, and even hormones might be net neutral.
Right.
But that's not, if all you've got is a hammer, then everything looks like a nail. And I use hormone replacement therapy. If I thought it was going to prevent dementia, I'd be out there banging on about it as well. Instead, I'm just talking about the science that we know about.
Yeah.
It's really good for treating vasomotor symptoms. And if I don't take it, I was on the pill until age 49. It was great until age 49, came off that, and within 7 days, I was just like, this is terrible.
Feeling it all.
Went back to my GP going, I haven't slept. And like it took 10 days until I started getting vasomotor symptoms. And I had 7 days of them before I went to the GP. And I was like, this is dreadful. She said, I was like that for 7 years. And I was like, well, I've been like that for 7 days. And so she gave me hormone replacement therapy, and it took about 10 days for that to kick in to manage my vasomotor symptoms and to manage the waking up at night because of the vasomotor symptoms, and to manage that feeling of like this adrenaline running through my body and waking me up and making me feel really edgy. So, but if I thought that it was going to prevent dementia, I would say that. But
there's
I don't
a lot of
think
fear
it
out there,
necessarily
isn't it? Yeah, there's a lot of fear circulating about hormone.
Yeah, but that's what drives an algorithm.
Therapy. Yeah, totally.
That's what drives an algorithm on social media. It's just all commercial people, driving messages for their own financial benefit.
I wanted to touch on genetics and personal health. I discovered genetic testing some years ago and found that I had one copy of the APOE4 gene, which is obviously associated with a higher Alzheimer's risk. So for somebody learning this information, what does it actually mean in practical terms without the panic?
I think that we need to be really, really careful when we're doing genetic testing and make sure that when we're going into that, we're not going into that without understanding, one, what are we going to do with the information when we find it out? Like, you've got the APOE4 gene, you've got one copy, not two. What are you going to do with that information, and is it going to change the way that you live your life? And are you given the right advice about what that means in terms of your risk and what to do with that information? So people need to understand before they get testing what changes they'll be making and exactly what it means. Like, don't send it off in the mail. I would be doing that sort of thing with a genetic counsellor and someone who can explain risk to you, because
that's good advice.
It can just make you freak out. Number two, I think people need to be really careful when they think about genetic testing, because you need to think about the implications for other family members who are genetically related to you, because as soon as you find out something about your genetic makeup, then they're finding out about their gene, their genetic makeup, and their profile of risk without maybe necessarily informed consent on that. So we need to think about what your understanding means for other people who may or may not have wanted to find that out. And that kind of way of thinking is pretty well established and thought about for people that have got things like, say, Huntington's disease genes in a family, whereby if you've got a certain you've got a particular kind of type of gene, you will definitely get Huntington's disease or not. And do you want to know whether you're going to get that or not? Because there's not anything you can do about that. Something like your APOE4 risk, you can do all of the things to reduce your risk, but we probably should be doing them anyway. And also in some parts of the world.
What are they?
Well, I'll talk about that. I just want to make the third point about genetic testing, because I think this is really important. The third point is you need to think about the implications that might have on health insurance. It might completely change your premium, and it could change other members in your family's premiums. Depends where you live in the world, what that's going to be about. If you say, oh, well, I know I've had genetic testing, you have to declare if you've had it done for your insurance. And so if you've had it done, then you have to disclose, and then that could affect your premium. And it can also affect other members in your families who haven't given consent. So genetic testing isn't just like cool and fun, like we've got to think about what that means. In terms of what we do to reduce our risk, we already know what to do to reduce dementia risk across the course of the lifespan. So there's the early life stuff, which is having good education, staying cognitively and intellectually stimulated and engaged across the course of our lifespans, starting from young all the way through. Don't kind of retire and sort of give up and sit around doing nothing. Midlife, we know hearing loss, is a massive burden there. And then lots of things that are related in terms of cardiovascular health and metabolic health and obesity. So doing all of the things to ensure that your heart health is well looked after, and cardiovascular health. Vascular is the important part of that because our brains are fed with this intricate interplay and network of blood vessels. So we want to take care of our blood vessels. So make sure that, your cholesterol is well managed, your blood pressure is well managed, your weight is well managed, if you've got diabetes, etc. And so we've got lots of different ways we can manage that we all know about, like eating a healthy diet, exercising, etc., and using medications if you need to. And then we also know that trying to avoid head injuries, and the highest rate of head injuries are men over the age of 60 climbing ladders to empty the gutters out. They don't
I always
not
tell my
climbing
husband
ladders
that
anymore.
whenever I see him on a ladder. I have that
You've
conversation.
got to stop because you'll bang your head, and that's terrible. And looking after your mental health, you don't want to, depression increases risk as well. So there's all of these factors. And then later in life, we've got vision loss, and we've got social isolation. So we've got these very well established ways in which to reduce risk. Your risk is just bumped up a bit. We're looking at these scales. You can't do anything about your genes. You've already got a bigger, heavier weight on the risk side based on your genetic profile. That's kind of like your baseline. So you're going to be wanting to put as many protective factors on the other side to try and adjust that back.
So what I'm hearing is, social connection is really important. Just having a community, that's one of the number
100%.
one. And I've heard that before from a neuroscientist.
Yeah.
And curiosity and learning. And that's the one thing I love about neuroscience, is the idea that the brain can keep adapting and learning at any age. So whether that's a skill, a language, a creative pursuit, or starting a podcast at any age, right? 100%. It doesn't matter what age you are, you can still develop your brain.
Yeah. And there's lots of cognitive skills that we know peak at midlife. We tend to think about all of the skills that peak in your early 20s in terms of processing speed and working memory. But later in life, you've got flexibility. You've got you're not so stuck in you're not stuck in your ways. You're not seeing everything in shades of grey. You've got pattern recognition, particularly if you've been in one career or discipline for a really long time. The pattern recognition's I've been doing neuroscience my whole life. Well, not my whole life. It's since I was 18. So I kind of know the pattern recognition's just there. I know what messaging matters and what helps and what doesn't. I just know straight away because I've been doing it for so long. So we should never underestimate that capability that we've got. And then the ability to see things of shades of grey. And then slower processing isn't necessarily a bad thing. It just means we're kind of stopping and resting. We're not growing and changing. We can be more thoughtful and careful. And being a matriarch is about stillness and imparting wisdom to other generations. And when you think about matriarch, there's a stillness inherent in that, which I think is perhaps reflected by the fact that it can take a little bit longer to process information or to remember a thing. But in doing so, we're pulling different threads of ideas together.
It's
and
like
then
a pause,
sharing that
isn't it?
with the world. Yeah, and we don't valorize that. We valorize the quick, sharp thinking of our youth and thinking everything is on the decline from then on.
You touched on hypervigilance earlier on, about being in a hypervigilant state. What about people that are wired that way? Those people that aren't the matriarch, can't sort of pause, be composed and reflect, the ones that are just firing all the time. Is that problematic?
I don't think it's problematic. I think I don't necessarily, as someone wired to be that way, there's a difference between having your sympathetic nervous system repeatedly activated, especially when you're asleep, to help you cool down, or people with sleep apnea, we see a very, very similar pattern where they keep waking up every time they snore. I suppose everyone kind of has a set kind of level in which, some people are just really energetic, bouncy kind of people, and other people are kind of a bit slower. I suppose it doesn't really matter. It's if it starts to impact you negatively and that it starts to wear you down, or it's more likely to lead to burnout, or it starts to have negative impacts. I don't necessarily think a kind of a baseline way of being is inherently good or bad. It's more like, what are the consequences coming from that? But I haven't really
Sure.
kind of thought that much about, because there's a difference between anxiety and then personality style.
I've been doing some courses on polyvagal theory and understanding the nervous system and how you're wired and
Hmm.
trauma. What are your
Yeah.
thoughts around trauma responses in the brain, and can you heal
I think
trauma?
polyvagal theory is being massively challenged right now. It's quite interesting. There's some papers that came out in the last maybe like 2 or 3 weeks ago from a group
Mm,
of neuroscientists kind of challenging challenging some of the baseline ideas of polyvagal theory and how easily implementable it is to, because there's polyvagal theory and then there's neuroscience. And even
mm,
though Stephen Porges, who kind of came up with polyvagal theory, is a neuroscientist, it's not necessarily well supported by all of neuroscience. So I'm not going to comment on polyvagal theory. And trauma as well, like, is an interesting beast, because
mm.
we have to be careful about the words and the language that we use to describe ourselves. And what we think about in neuroscience is being very careful with our definitions so we can carefully study and manage and understand something. We know a little bit about early childhood trauma and how that impacts people across the lifespan, but there's different types of trauma. So say if we look at trauma in terms of, and I don't even like talking about this when it comes to kids, say like physical abuse or sexual abuse or that kind of physical chaos in early life, those kids often go through puberty earlier. It's almost like there's this kind of evolutionary rush in their bodies to like hurry up and
Get out.
mature, to quickly get out of that environment. And those kids might go through puberty earlier. Those girls then will be particularly vulnerable to mental health issues, because when your body and brain changes separately from your social cohort, that increases your risk. Kids who
Mm,
have gone through neglect and poverty, you think about like the extreme examples, like be the Romanian orphans who were just kind of left in cots, so fed and watered and that was it. Or
mm.
kids that have gone through impoverished experiences where there hasn't been a lot of enrichment and engagement. They weren't beaten up, but they were just neglected. They kind of go through a bit of a slower development. It's almost like their bodies and brains slow down to try and like get a few more kind of inputs. It's like
Interesting.
let's make childhood a bit longer for those kids is kind of what their bodies and brains are doing. So we need to be careful when we're thinking about trauma, because that impacts the onset of puberty. Then when you hit puberty, the social context in which that happens is massively important as you're entering then into adolescence. The context and the social interactions that you're having will influence your set point going forward as well. It becomes like a blueprint for if you always experience anxiety and depression and adolescence. It's almost like that's how your brain kind of learns to experience the social world.
Right.
So it's not as simple as the information that's carried in the parasympathetic nervous system within the vagal nerve. It's much broader and more contextual than that. So I would encourage people who are thinking about polyvagal theory to sort of zoom out a bit and then look across the lifespan. Then we've got to look at all of the ways into helping people with that.
Absolutely. I wanted to touch on biomarkers. I know, we understand that biomarkers in our blood results can be clues to what's happening with our health results. Are there blood tests or biomarkers that can give us insight into our brain health or cognitive risk? You go in, you can get a liver
Yeah,
test
I
or a
mean,
this test. Can you do that with blood?
you can, but again, outs- outside of outside of the commercialization of let's scan and screen everything right now, which is the longevity bros setting up the clinics, the wellness empires saying let's test everything and scan and screen everything, and the more information you've got the better, is at odds with what we would see within health and medicine and public health if we were getting the government to fund these kinds of things. It's like, are we going to scan and screen for everything? Because what are we going to do with this information, and where can we intervene and make changes? So it's about, well, why are we getting a particular test done? And when we've got that information, what are we going to do with that going forwards? Some people say, I need sovereignty. I need to know all of that information about myself, and then I can make changes. If you want to spend your own money doing that, then go ahead. But there's a lot of inherent privilege in being able to do that because that testing isn't available to the vast majority of the population, whereby we're still trying to do the basic public health interventions of, vaccinations and diet and education and,
Sure.
access to healthcare, getting your blood pressure checked, dealing with obesity, etc. So it depends on who you are and where you're coming from when you're looking at biomarkers. Some people maybe at midlife are going and getting your APOE tests like you did, or looking to see have you got blood biomarkers of, maybe Alzheimer's disease markers. Typically within research, we're doing that for a particular reason because perhaps someone's had some mild cognitive decline. They've gone off to a memory clinic. They're seeing a neurologist or someone who specializes in that space. And it's like, well, let's see whether, we're picking up any biomarkers of something like Alzheimer's disease. And then what interventions are we going to be doing from then on? So I always think when we're doing these things, the broader message to the population is why and
Yeah.
what we've got, say people just go and have like these full body MRIs, right? Once you reach age 50, there's going to be stuff showing up on that MRI, and then your brain is going to be focusing in on that. There's actually a movement within healthcare that if someone just has had like a bad back for, lower back pain, whatever, they're always achy, and then they go and you have an MRI to see what's wrong. It actually makes the back pain worse because your brain starts to like focus on the pain and uses the MRI results as a kind of another signal coming in. And so there's a movement away from kind of over-testing, over-treatment, over-screening, over-diagnosis within healthcare because we, one, need to think about resource use, but also, two, the reactions and responses that people have to getting data and information.
And it's
And
making us
particularly if you're
anxious.
posting stuff away and then you're getting that information back, and then what you're going to put it through ChatGPT and ask it for advice. There's some really big commercial players out there who are pushing us to do this without understanding about what are we going to do with that next. So I do think we need to be thoughtful and careful about the testing options that are available, particularly if you've got money. And I
like
don't
you
have a lot
said,
of sympathy.
the anxiety it can cause for people if
Yeah,
you're
and the
already sort of
anxiety
predisposed to,
can then cause their symptoms to be worse. So we don't scan, we don't just give someone an MRI because they've got sore knees or a bad back, because by virtue of having the MRI, it makes the pain worse. Because
Yeah,
people
for
then
sure.
hyperfixate on what's going. They don't. The current clinical practice guidelines are not to do that, which sounds counterintuitive. Where it's got the longevity bros in here saying scan and screen for everything, but that's all right because they've got the money to go away and tweak, the kind of the peak performance kind of indicators. The general population is still trying to deal with the basics. So I guess I try to think about what's more relevant to everyone all of the time, not just those peak performers. Probably depends who you are listening to this, where
And so you
you
talk
fall.
about something that perhaps a general population can use. What about creatine as a supplement for brain function? There's a lot of hype on that. What are your
Oh,
thoughts?
yeah, it just got invented as well. Well, no, it didn't get invented. It's got lots of data behind it in terms of lifting weights. If you do lots of strength training and you add some
Performance?
creatine in, it'll, help things along, but you can't just take creatine and not lift weights. The evidence around the brain is a lot more sketchy and thin on the ground at the moment. But again, it's been marketed like it's like you can't we'll probably say the word creatine and my phone's listening and it's going to start sending me
For
creatine ads
sure.
soon.
Yeah.
Because there's a lot of people jumping in on this. I always say I got AI to design me a jar of creatine for midlife women and brain fog, and it's called Fog Off. Dr. Sarah's Fog Off creatine for midlife women's brain health. I could
It
probably
would
retire
sell.
next
That
week.
would, I
It would.
think so too. That's the
Everyone would
thing.
buy it. But I'm not
Hmm.
prepared. Ethically, that's just ludicrous. I'm not prepared to go down that path. I'd rather educate people. But to be fair, I could retire next week if that's what I decided to do. Um, the data, we've got some very teeny tiny studies of like less than 40 people looking at some brain health indicators where like you kind of smash back some creatine if you haven't had a good night's sleep, and let's look to see what our memory performance is like. And there are, you might score a point or two less. But the data is very sparse on the ground in terms of saying everyone should be using this all of the time. That said, there's not necessarily many downsides, and it's got quite a good safety profile. So have a go
I
at
use it, and
but
I have
is
to
it going to
say
be
I found that it made me I felt a little more sharp, but again, you don't know whether that's placebo, and that's my brain going, hey, you've just taken some
100%?
stuff that's meant to be really good for you, so you're going to be feeling amazing, by the
100%.
way.
And this is why we need to do randomized controlled trials, because then that takes
Mm.
into account placebo effects. But there's probably, and we've got a good neurobiological story in there whereby I talked about one of the changes that we see in midlife brains is the changes in how neurons metabolize and kind of like the energy kind of pathways that we've got inside neurons to create ATP, which is kind of like we always just say that's like the energy currency of a cell. And changing levels of hormones in some people can change how efficiently neurons metabolize, and using creatine kind of sidesteps a lot of those pathways. So it creates this readily usable form of energy. And so for some people that might help. But have we got enough data to say everyone all the time should be using this in the same way that we fluoridate water, for example, or talk about blood pressure, or talk about what's another broad scale public health measure, like encourage everyone to do exercise? I mean, maybe down the track that will actually be the case. And also buying a pot of creatine from Woolies or from your vitamin bros, I call them ice bath boys. You can also eat creatine by eating meat. We've got actually natural sources of creatine in our food supply.
More is more in our
evolve
society.
pots of creatine being sold in the jungle.
Mm.
And
Yeah.
I'm so cynical about the commercialization of women's health right now. That's why I'm being slightly narky, because we've got to just stay alert to what we're being sold and marketed versus what is necessary and what is going to be helpful for the most people.
Absolutely, because it's exhausting trying to keep up with it all. It's like go on HRT, and
Yeah,
then some people can't take HRT, and it's like, well, am I going to get dementia? Maybe I should be
no,
taking
you're not.
creatine to help.
No, you're
Maybe I
not.
need to up my fish oils. And people, it creates fear among a lot of women.
It does.
So,
And when all you've got is a hammer, everything looks like a nail, and it's really easy to be glossy and market stuff to people on social media right now. It's just the kind of the current vibe of the planet. So it's hard to not succumb to that.
What are the common myths around brain health you wish women would stop believing?
That without HRT, you'll get dementia. That all women all of the time, hormone shifts are responsible for brain dysfunction and decline and instability. In some women, some of the time that is the case. All women all of the time don't get PMS and are riding a hormonal roller coaster across the course of their menstrual cycles, but there is a subset of women that do. So this idea of taking a snapshot and assuming averages apply to everyone is very, very unhelpful, because we've got some women, it's like going through menopause. Some women don't notice anything. That's fine. Just sail through. Other women are on their knees, right? And that doesn't mean we've all got the same experience and we should all take the same approach. And so that is the same for many aspects of brain health. So that drives me a bit crazy. And I suppose,
it's
and
so
that all kind of goes
complex,
back
isn't
to
it?
this. Sorry?
It's very complex, isn't it? Like you spoke about how some women just breeze through menopause and other women, like you said, are on their knees. There's so many different complexities because of that reason.
And my experience isn't going to be your experience. And so we need to be careful about messaging that assumes
one size fits all.
One size fits all. And I think that a lot of that kind of goes all the way back to messages that we may or may not have received. And as I said, I didn't grow up in a family with that message that as soon as you hit puberty, moodiness and crankiness is due to hormones.
Yeah, see, I
And we've
did, which is interesting. But perhaps
yeah,
also that generation didn't really, some spoke about it, some didn't. It was still a bit, I grew up in a house
yeah,
full of
and
girls,
so it's
so we spoke a
hard.
lot
Yeah, it's
about
hard
hormones.
to tease out. And my mum was very open, but I didn't grow up with the message that there was a problem.
Mm,
So
mm. So
we've
that
got to
gets into
take
your
into
wiring.
account the stories that we're told. And if we are telling girls as soon as they hit puberty that you've got a female body and brain and you throw some hormones in, it's about dysfunction and instability and decline and depression and PMS, then
If
you
that's
grow
the
up with that
story.
story. And so then you
Yes.
expect to experience that. And then you're much more likely to have an experience if you're looking for it. I didn't know baby brain was a thing before I had my boys, and I also never
Mm,
experienced baby brain. And I'm like, was I tired and did I find it hard? Yeah. But did I go, oh, my brain is broken, I've got baby brain? Well, no, because I'd
mm.
never heard it. It wasn't part of my narrative. And
Yeah.
so would I have talked about feeling tired or anxious or lonely as baby brain and assumed it was a broken brain? What are you attributing things to? And so we need to think about that across the lifespan as well.
Mm,
What's the source of a particular thought or feeling or behavior, and what do we misattribute that to? So,
absolutely.
I'm
So
being very muddly now with my messaging.
no,
Sorry.
no, you're being very clear. So self-connection is the heart of what I do. How does understanding our brain change the way we relate to ourselves, would you say?
I think self-awareness, I'm not a psychologist or a coach. I just like talking about neuroscience. But one of my colleagues, Dr. Mary Collins, who I teach one of my courses with, she's a coaching psychologist, works in the Royal College of Surgeons in Dublin in Ireland. And she always says self-awareness comes first. So having an understanding about yourself and your thoughts and your feelings and your behaviors and how a thought can trigger a feeling, which could trigger a behavior, having like awareness of that is first step, and journalizing that and maybe like writing it down on paper or talking about it with someone or is the best way to kind of be objective. And until you have an understanding of, your habits or you know, just your behaviors, you can't kind of take the next step to intervening, or do I want to change or not, or what's underpinning that? Why am I responding in that way? So for sure, we have to have self-awareness first.
I love that. That just made my heart sing. That is the essence of what I believe as
Mm.
well. After everything you've learned about the brain, has it changed the way you live your own life?
It's very hard because I've been studying neuroscience since I was 18. um, so it has been how I've lived my life. Look, like I say, I've never had genetic testing. I don't do saunas or ice baths or any of the things. And, I know about all of this stuff. I protect my sleep is number one, first and foremost. I try and protect that. I understand, we can say, oh, buffer stress. Don't, try and manage stress. Crap can happen. Like the last couple of years, we've had some kind of really crazy stresses on my family that were very unexpected, and not just, let's just manage the stress. It's been all consuming. And you have to give yourself some grace in there and not just think, how can I fix this and manage the stress for my brain health? So I'm just trying to be like thoughtful and logical about my approaches to that. So if I can protect sleep, understanding that social connections and communities are one of the most powerful sources of resilience, but also there are times in life when you just don't have the people around you that you need or want, and understanding and again giving other people and yourself grace in that space. And yes, and then the basics of just like, moving my body, exercising, understanding sometimes like you've got a really sore knee for like 2 months or tennis elbow, and so you can't just follow your gym bro routine because something hurts, and that's okay as well.
Mm.
So
And I think that
like
really
there's nothing
talks
magic
back.
there.
It
Sorry?
talks back to that self-connection, that self-awareness,
Yeah.
And like you said, shit does happen, and it's having the ability to be able to be in the trenches and then be able to bounce back. It's how quickly
Yeah.
you can kind of, not quickly, that's not the right word, but it's how you
Yeah, I
bounce
know. Yeah,
back.
it's not, yeah, it's exactly that. So it's very easy to say sleep and socialize and sweat and be in the ocean. I used to always be in the ocean. Now I'm a bit scared of sharks. And it's like, well, that's okay. I can just paddle, go in the ocean pools, here in Sydney. Um,
Yeah.
so it's all of those things, but then also understanding that life is like complicated and unexpected, and we need to be kind and to give ourselves grace and just kind of be a bit kind of gentler in that
Mm.
space too.
Is there anything important that you feel we're missing before we wrap up today in this conversation?
I think just think about where you're getting your info from. We've got like the social media ban, in favour or not, whatever, here in Australia with kids. We're so busy flogging the teenagers and telling them that they don't have digital literacy or understand, and we don't think about where midlife women are getting our info from either. And there's some pretty shiny, glossy influencers out there who don't necessarily always have your best interests at heart. And so just be a bit skeptical and mindful about information.
Mm. Before we wrap up, I'd love to offer a moment of reconnection, something that I ask every guest. So, when in your life do you feel most connected to yourself, Dr. McKay?
Probably when I'm like at the beach or in the natural world, perhaps when I'm in the sea, in the ocean, although I'm not going
Mm.
too deep right now, as I said, because I'm scared of sharks.
Ankle deep, yeah. What has your body taught you over time?
Sleep is just the foundation.
100%. Yeah. And lastly, what is the most powerful advice anyone's ever given you?
Most powerful advice anyone's ever given me. Mel Robbins actually just said, just ignore all of the haters. She said,
Mm,
just people won't like you, whatever, who cares? She didn't actually say let them to me, but I think that that's quite useful. It's like just kind of ignore the bullshit.
yeah, that's great advice. I had a friend, a mentor who was a counselor that once said to me, "Congratulations, you're making enemies." And I was like, "Oh." And he said,
Yeah.
"It means that you're standing true in yourself. You're being
Mm.
authentic. And sometimes that's going to rub people up the wrong way, and that's okay."
Yeah. Doesn't
Great.
really matter when you reach a certain age, I
No,
guess.
totally.
Got many other
Exactly.
things that matter more.
Absolutely. Sarah, thank you so much for sharing your wisdom today. When we begin to understand how our brains work, it expands our thinking and opens the door to seeing ourselves and this stage of life in a whole new way. Where can people find you and purchase your book, The Women's Brain Book?
Well, the Women's Brain Book's in all good bookshops or online. DrSarahMcKay.com is my website and the portal to all things me.
All Things Brain. Love that. Thank you.
You're so welcome.